We'll just wait for a few minutes and then start. In the meantime, if you have any questions, I can take those also. Yeah. Okay, I guess we can start. So welcome back. Today I'll be covering topics like file input and output. So how do we handle IO, essentially input and output in C++? And then we might see some STL classes, like standard templateized library, some useful containers, and maybe some function like methods, some useful functions from member functions from them. Um, yeah. If you guys have any questions from last time or previously, like anything, you can ask me. Else I'll just start now. Uh, okay. Just to recap, last week we saw operator overloading, where the equal to operator itself so gets you can overload it. So one way is to have like different arguments passed to it. So the equal to operator itself gets overloaded. Then the other kind of overloading is the bracket operator, where essentially it's a dereference. So um, what happens is you have to define the bracket operator overloading. So for example, let's say for a standard vector, it doesn't matter what the template is. We can access its element by writing a loop and then using the bracket operators and then just giving the variable. Now the nice thing is internally, standard vector itself has overloaded bracket operator, which looks something like this. Uh, it takes size underscore t. Underscore t is essentially the largest integer you can represent on a system. It automatically gets assigned to that. And then it returns, okay, the whatever the pointer it is has internally to that vector, right? Plus I, and then dereferences it. After that, whatever dereferenced value it gets, it just returns that. So, sorry, essentially that is what the bracket operator does. Now, this is also a form of overloading, okay, where you can overload this bracket operator. And let's say you are writing your own container, like here this standard vector is from the standard template library. Now, if you want to like I should have entered standard vector, sorry for that. So if you're writing your own custom vector class or any such thing, any such container, then you need to, let's say you want to use the bracket operator, you have to overload it and then write some function like this. Okay. Right. Next, yeah, then we saw how to use templates. So one example for that is you can have like function, let's say a max function, which compares two values. Now, if there are two integers, the body itself is straightforward. So you compare x and y, and then um, if x is greater, then that gets returned. If not, then y gets returned. You can write the same if else statement with a ternary operator. This question mark is the ternary operator separated by a colon. So the if part or the statement which gets evaluated as the boolean as true or false, that gets that stays left to the ternary operator. Then the true part itself gets like whatever you want in your statement that you put, and then like the else part or the false part, you put it in after colon. Okay, so essentially these lines and this line itself are equivalent in the sense that they perform the same thing, but performance wise there is a slight difference because if else need to go through every there will be a lot of branching. With ternary operator, that is not the case. Okay. Uh, and then when we see the same max example, but comparison of x and y is now with doubles. So the body is exactly the same, and even the ternary operator also. So what we see is we are uh, essentially writing the same code just for different data types. and uh, essentially it's not necessary. It's just code bloating. So one useful thing in C++ is using templates. So maybe I'll have using templates like this, where you put some kind of, let's say, class T or some type defined. You can have anything, like depends. Let's say you just want to use the inbuilt data types, so you can just put those. And then this T itself stands as a stand-in for the type of X and Y that we want to use. Now the return is also templatized, right, for the function. The input parameters it takes, X and Y, are also templatized, and all of them are represented by this T. The nice thing is, when we go with, let's say, defined A as some integer, B as 8 some integer, C as some doubles, and D as also some double, we can return I max with I as the integer equals to max, and just we have to pass the template as the data type that we're actually of the values that we're actually passing. Okay, double, because C and D are doubles. And the nice thing is you can just call the same function, same lines, and just pass the arguments appropriately and then get the values. Uh, Again, to reiterate, uh, templatized functions themselves do not exist inside the code unless they are actually instantiated. In the sense, what I mean by that is, uh, when I actually call integer max with integer passed and then values, then only this a copy of this code, like something like this, gets created, and this gets compiled. Okay, so it is known at compilation time if this function, let's say it never gets called. So what will happen is your function max with template T will never be even compiled, because it doesn't need to create any of this function with double or with integer. Okay, this is the important thing about templates, that they only compile the code only when it's sort of necessary. So because I'm calling integer and double, so both these lines will exist inside the code, and the function will appropriately map to whichever region whichever code region it wants to call. Okay, uh, like we see that the code itself doesn't change much, so we can just use for most of the data types. So comparison of integers with integers or double with integer and all that. Uh, the comparison itself doesn't change, so you can reuse this for other inbuilt data types. Okay. We also saw the other way of doing the same thing. You can replace the max function with a macro, like we did here with a hash defined max. Now it is a valid way of writing the code, but it's definitely not recommended, because uh, macros can, like I mentioned before, macros are pre-processors. They are evaluated even before compilation, and then perform. Let's say there is a bug, and debugging that becomes much difficult. Okay, so there's a much cleaner way, and C++ actually is quite useful for, like, one of the reasons it's quite useful is because of templates. So do take advantage of it while writing your code. Yeah. I hope this is clear. Then we can start with other topics now. Okay. So one thing that we have been doing since the starting of these sessions also is, uh, we always include this file. IOStream. Now we'll actually focus on this today. We always know that we have to include this file in whenever we want to print something or get some data from terminal or whatever. So let's look at this with a bit more focus. So I'll have integer main, okay, and return will be 0. And usually what we do is we write some integer a equals to, let's say, 8 point, not point. 8 and then some double. Let's say B equals to 4.3. Now, a normal way to like what we do is we usually just use the standard C out, right? And then if we want to print A, we just print it like this. This is the what I'm essentially saying is this is the format that we're familiar with to print something. But let's look at this a bit more closely. Uh, and of course, something which everybody is familiar with when they start with program. So let me put that also. Hello world line. Okay. Format this. Oh, correct. Let's just quickly run this program so that we are confident that we are confident of what we expect also. Okay. And okay. Awesome. This is exactly what we expected to do also the after compiling and running the program. The hello world gets printed and we had some variables A and B, we just printed those. Now let's look at the uh, portions. So what actually is happening is cout is a operator. It's a not an operator. It's just a function defined in standard namespace. Okay, where it takes a stream. Okay, so essentially input output. So this is IO stream, right? So input and output streams in C++ work this way. So whenever you want to input any data to the program, so this is my program. If I want to output any program, any data from it, I use standard cout. Let's say I want to just print to terminal output or the screen itself, right? If I want to get some data, I use standard cin. I normally don't use it, but we can take example also here. So let's say I define. Um, I think it should work. Um, I'll just write it so that it's more clear. Anyway, so I'll define C, okay, and standard C in. Notice the opposite. So here I use the left shift operator. Here I am using the right shift operator. It's a it's designed by the standard, and we'll look at it more closely. But do notice the difference. Okay, then what I'll do is after the input, I'll just print this. Okay. Now it's expecting some value, so I'll just give the value. I do have not maybe not 4, 9. Yeah. So as you can see, it was waiting for me to input. Okay. And after getting my input, which and the way it knows to end is end of line actually. So if I press enter, which creates an end of line uh, trigger in a way, so that then it knows to exit. Okay. Now after it exited, the other print statements came, which is what the code will output to the terminal. Okay. So first the hello world, then the A variable, then B, and now the C is because what I entered is gets stored inside C. That also gets printed. I entered 9 and C as and when we print C, we get 9. Okay. I hope this is clear. Now let's look at each portion separately. So as I was saying, whenever we want any data to move from the code out of the code or into the code, C++ has a way of handling this. These are called streams. Now, in a stream of cout, you are outputting when you're trying to output. We use this left. These are overloaded bit like left shift operators. Okay, so essentially you can think of it like you have a string of like bits. Essentially, it's like these are characters, but you can think of it, essentially these will be ones and zeros. So those get streamed to cout, which says whenever I have a screen or output to a terminal, I'll print this, I'll output this value. So those values get streamed. Okay. So that's the idea behind left shift operator. It streams these values into C out. Okay. Then again, additionally, what we do is we stream this function also. So standard ENDL and all. Now the usefulness of standard ENDL is it's essentially uh, so what I want to do is after a hello world, I want to enter a new line. I can do that by using this character slash n. So writing something like this. So something like this. So notice when you enter characters like this, after it encounters a slash, so these are more special characters, where a slash n essentially represents a new line. So if this gets uh, passed or streamed to C out, it will interpret as a new line. Okay. What standard ENDL does is it enters a new line and also uh, a flush of stream. What does the flush of a stream mean? It means that there is actually a buffer gets created when you're trying to pass stream any data. Flush means it will enforce that the whatever is there in a buffer is like a temporary, you can think of like a storage or something. So the hello world first gets to a buffer. So that buffer gets pushed out. So the buffer clears, as in this data, which is first gets into the buffer, gets into the output. So which is this output that we see. Okay. So it forces a flush. This is essentially standard ENDL has two, it's like combination of these two function. Okay. Now you can, so if you want to use just flush without the slash in you can, I hope you understand. If you want to use end of line, you can just do slash in. But if you want to use just flush of string, so you can just use standard flush. Okay. The same thing, instead of standard ENDL, you can just put standard flush. Okay. Now, only thing is that standard ENDL combines the functions of these two. Okay. Similarly for sorry, similarly for A, B, and C. So it doesn't matter if your data type is integer, double, or any other characters, you can output them. And the overloaded operator already knows what kind of stream it is getting because from the data type of whatever variable is being passed. Okay. That's a nice thing about C++. During compilation itself, it will know which kind of, because they're passing the types which are known at compilation time, it can know and do optimizations, right? Now, because here I use characters, so essentially these print within double quotes are characters, so it knows, okay, I have to push characters now, and here I have to push integer, here double, another here integer. Okay. Uh, Very similarly, standard scene also, it's the input string where it says that whatever I'm getting from outside the code will be inserted inside this variable C. This is what I did here. I just ran the code, entered 9, and then I pressed enter. So that gets stored at C. That's what gets streamed. And then after that, we have the other code which runs. Okay, right. So far, I guess the good. If you have any questions, to feel free to stop me. Okay, right. In that case, next is so these are, as you can guess, useful in many cases. We want to print statements to know the output of the data or get some error messages and whatnot. Okay. Now let's look at another case of the same IO stream. Yeah. So not only that, you can just print data or characters or get data. You can actually also uh, manipulate the values that you're trying to print and such. So let's take some example. So I'll take let me start here. So I'll have some integer, let's say 17 on L, which will be just with some example I'm taking from the slides itself, right? But I hope I'll not say what the uh, value is, but essentially this is like we have an integer I, which is 17. Now we have a long, which is a hex. Okay, so if I'm not familiar with hex, I essentially think of it like as we represent normally numbers with base 10, as in each character here. So each place is up to 10 digits, like up to 10 numbers. So from 0 to 9 is like those numbers represent uh, those numbers are here, and then from here and so on. So essentially it's like another way of representing numbers in binary. We have zeros and ones, so each uh, place takes two values. So if it's base 10, then it takes 10 values, and so on. And in hex, it takes 16 values each place. Hex uses 0 to 9 for 10 numbers, and then from A to F for the rest six numbers. So 11 to sorry, not 11, 10 to 15. Uh, those numbers are represented by letters. Okay, A, B, C, D, E, F, and all. So that's essentially this. And we'll see the usefulness of manipulating. You can actually convert, like print and convert uh, these values also. So I'll have another large value which I'll call as I64 to mean this is 64-bit unsigned integer. Okay, I'll store the value also. So this is also a large number. Then
So,
yeah, going.
but you have mentioned unsigned integer I64, right?
Yeah,
Okay, I64 is a variable name, right?
yeah, yes.
Okay, okay. And long is a data type.
Correct. So you can qualify any of these integers, like obviously unsigned is like one kind of data type. So long itself may make sure that you're using a larger um, uh, type for that. So in general, integer is 32-bit, and when you put long, it becomes 64. But I have put twice because it's just a it's not necessary, because generally all systems are either 64-bit, and you get when you do long, it's just overkill, but it's okay. You can get away with long itself. Okay. But here is
If
just
I
yeah.
if I am not using, sorry to interrupt you. If
No,
I
no,
am
that's
not
good.
using long, then does it gives error?
It so it will try to more of a, so if you don't put this and then give a very large, actually this is essentially a very large number. You're putting the a very large number inside a 32-bit integer. So it
Yeah,
will be
yeah, I got it.
it's not like
No,
it won't
I'm
give you
asking
error.
about long. Means does I have to mention two times, or if I have not
Yeah,
mentioned two times long, then it will give me error,
yeah,
or
that's what
it
I'm saying.
depends
So
upon the compiler.
it won't give you error. So when you have just unsigned integer, let's say you don't have long. So unsigned
Hmm.
integer is 32-bit, still 32 bits, and the number
Oh,
that you're passing to it is much larger. So it will have an implicit that if you learn this, so it will do an
casting.
implicit casting exactly.
Yeah,
So you're representing a larger number inside a smaller space. So you'll have some data loss there. It's not like it will
yeah,
give you an
got
error.
it.
Yeah, it's not like it will give
Got
an
it.
error, but yeah, you'll have loss of data, which is again erroneous. Uh, so we'll have float and and so this one is just divide by 7. Okay, that's okay. Then double D equals to, let's yeah, store the same thing by 7. The difference is that we are performing the same calculation, and obviously 15 is not exactly divisible by 7, so we'll have recurring decimals. I mean, it's like, yeah, it's a recurring decimal, but we'll have, it's like infinite digits. Now, float can only represent so many digits accurately, and double can represent much more. That's essentially the idea here. And we'll have character C equals to x, and then const character pointer s equals to 50. Yeah. Or we can take some initials from the chat. I'll probably take VKP. Yeah. Okay. And we have one more. So integer pointer equals to, store the address of yeah, my bad. Address of I inside this pointer p. So it should point to the same uh, I, same value as I, right? Okay. So now since we have all of them, let's print each of them. So first I'll print I, and instead of putting just space, I'll just end the line. That's all. To know, I'll just modify it a bit more to know what we're actually printing. So I'll just put I as such. Okay. Next is yeah, let's do this. We probably require standard, but let's see. Then yeah, we have a long. Long, then add 64. Then F, D, C, S, then avoid pointer type transfer. So essentially, it's like we're ignoring the um, type of S. It was a character pointer. We're just saying we'll make it void. It's a void pointer of S. That's it. And then P again. Yeah, we're not dereferencing it, so it just should print the pointer itself. But let's see the output. This value should be 2. Yep, this should be in standard as expected. That's good. Why is this an error? Maybe it needs single quotes. Okay, great. Apparently, a single character needs to be in single quotes. So, okay, yeah. Uh, as first, I think we let's just go through what I did here. We had different data types and just named different variables. and we want to see how each of them perform. Okay, so like we want to try different outputs and all and see how each of them look like. Now, first of all, I think the first line is clear. We're just printing I, which has 17, so that printed 7, 17. Now the next thing we're doing is putting we're printing I, but in a hex form now. Okay, now I itself by default all numbers are decimals. Okay, so 17 here is actually a decimal number. When you're trying to print it, it will print in the decimal form. You can actually temporarily for this line just say that I want to print to the stream. I'll print this exact character within this quotation hex I. That's what you get. But extra thing I'm saying is I'll print hex onwards. Like whatever input I'm getting right now onwards, I'll get hex. So when you pass I, which will be some ones and zeros essentially in machine language, but they'll be printed as hex. Okay, that's what happens. So 17 gets represented as hex. It's a very useful way of even converting numbers from one base to the other. Obviously, it has to be supported. So standard supports hex, oct, and obviously the default decimal and binary. Yeah. So and then we end the line. So that's what we get. Similarly for oct, we print I 17, the number 17 in oct, and that is 21. In hex it's 11, in oct it is 21. The next is long. So we had this uh, I64 taking, sorry, L taking this hex and then printing it. The question. Okay. So printing that O the 0x after. So one thing to note is numbers uh, like hex and binary and decimal and everything, they are represented like one convention of representing them is with this way. So the 0x or 0p or 0d or whatever, that represents what's the type it is. What is the base you are representing the number. So x means hex. So after that, the actual number is actually this. Oh, sorry, I don't think it is getting clear. I'll just put this and then I hope this is clear now. So from 0, 1, 2, and so on, that is the actual hex number. And now what we're doing is uh, representing, like saying that this is a hex and then stored in L. Thing is, when you try to print it, it will not print the exact uh, the form of the what number you're passing. It will print in decimal. So same thing, hex number in decimal represents something like this, a large number. Okay, hence the long used. Now, similarly, you can actually represent a much larger number. We just extended it here in I64 variable and use long. Now, the thing is, important thing to note here is that variable names should not start with numbers. They cannot. They need to start with letters and then you can have numbers in between. That's okay. That's allowed. But essentially, it should not start with numbers. Okay. It has to start with letters. Now that's just a define like standard defines that way, C++. Okay. Then we extend the number. Fine. Store it in I64. Okay. Now I64, when we try to print, similar to case to L, it is a hex number, but stream by default outputs in decimals. So it will take this whole range of bits. Okay. It's a hex, sure, but in machine it will be much larger um, bits. Okay. So all that bits now converted like that number, whatever corresponding number represented in decimal, okay, is this number. Okay, that's what it outputs. And then in F we store 15 by 7. So this is the what do you call the output to F and the output to D. Now thing is, by default here it just showed us a few digits, so like 5 decimals here, and similarly for D. What we'll also see is we can actually extend the decimals it represents. Actually, maybe I can just do that. what you have to do is include a header file called IOMoney. I hope I'm correct in this. Yeah, let's see. Uh, okay, IOMoney, and then you have to enter standard precision and then give what do you want to how many decimals do you want? So let's say 8. I'll just put that. Okay. Let's see. I hope I did that correctly. Standard precision. Oh, sorry, set precision. Great. So we see that till 8 also they are matching. Let's go like 16. Okay, good. So now we see that there is a slight difference. So after like 1, 2, 3, 4, 5, 6, 7, yeah, about like seven, after 7 decimal, we see a difference. So uh, the actual more correct answer will definitely be the double because it has more digits to represent. Okay, but the thing to remember is because f is a 32-bit float, it will only store values correct to a certain decimal. Okay, essentially because it has only 32 bits it can store. Because double has 64 bits, it will be more accurate, and the actual number, if you try to calculate by hand and see the accurate decimal places, it will be more accurate to much more decimals, the double, the D variable. Okay, so yeah, and after certain numbers, it will be also garbage because it cannot represent those numbers anyway, right? So there is a thing called machine precision where the values after a certain time anyway can't be represented by the computer. Okay. Now these are defined by the standard by IEEE. So floating point numbers representation, both in 32-bit and 64-bit and higher bits, not lower bits, is defined by the standard. And even that is for floating point numbers. For integers, there's another standard, the 2's complement. Uh, it's like essentially powers of 2 you use to represent integers. So the nice thing there is you don't lose number, as in, so let's say you have 32 bits, so you can represent 2 power 32 numbers essentially. Like if one is 0, then it's like 2 power 32 minus 1. But I hope you get the rough idea. So because I have two combinations for each bit, so 32 bits I can represent like a 2 power 32 combinations. And if I start with 0, then what's the maximum number I can represent is like 2 power 32 minus 1. That increases substantially to 2 power 64 minus 1 when I have 64 bits. But yeah, so the nice thing is you can represent all the numbers in between exactly using those bits, right? Because every combination will give all the numbers in between those, like from 0 to 2 power 64 minus 1. But it's not the same with floating point numbers. It's more like as the numbers grow, uh, what you get is just a range. So let's say you can represent only to 10 power 308 or something in doubles, 2 power 60 in the 64-bit floating point representation. So numbers closer to 2 power 300, 10 power 308, you'll get like so let's say values from 10 power 307 to 10 power 306. A lot of the values you can't exactly represent. There are a lot of values there, of course, but most of them you won't be able to represent exactly. So a single representation of bits, a combination, will represent a lot of these values. It gets that's the way that standard has been defined. Okay. Uh, right. And then moving on to the next example, C. So C, we put the character as X. So that's what it prints. That's okay. Then we have another variable S, which is a character pointer. It can store more characters, so VKP. So it prints that. Then we just typecast the S to a void pointer and then try to print. So it prints some uh, garbage. Yeah. And then what we try to do is print P, which is the address, which stores the address of I. So it prints the address. Okay, nice. Next is okay, we can take this example also. Um, because I said this. Okay, remember this left shift and right shift uh, this notes note. Just give a second. Yeah, sorry about that. So remember that this the left shift and the right shift. I don't have it. Ah, yeah, yeah. The right shift. Uh, how do you put it? These are actually operators. Okay, and operators you can overload. So the to make this idea more clear, I mean, obviously here it is overloaded to include all these data types that we pass from integer, long, unsigned integer, float, double, character, constant character pointers, integer pointers, all kinds. So you can pass any of this, right? But to, I mean, it's overloaded inside the standard. Okay, sure. But to see it bit more clearly, so maybe we'll take another example. Yeah, I'll include I have a string, I have integer name as I do. Then yeah, but this time what I'll do is because these are overloaded, what we can do is use the same idea for our custom defined variable, custom defined type. So as soon as I say custom defined type, what you should think of it is classes. Now class are something that we routinely use in C++. So let's uh, write some useful things to extend our classes. So we'll add again, we use the complex class. Okay. So double, we saw this before. So essentially what I'm doing here is defining private variables RE and IM. So no um, qualifier, but by default, then they will be private, and then have a public function. Okay. Which will be the constructor taking values double RE and double IR and then sets them. So our E takes underscore RE and IM takes underscore IM. I don't need any body for the constructor, so I can just leave it empty. What I'll do here is now I can have lot more functions that we saw. I can have norm for this vector. It's essentially vector, right? So I have two components. So some one number, another number. So its distance from origin, I can have a function to calculate. I can add two number. I can add two overload. I can have overloaded functions to have add two complex numbers, subtract, multiply, or etc. Now, what I'll do here is have uh, a specific function, right? I'll make it a friend function. So use OString. So inside the IO stream, we don't just have standard cin, which takes input values and output values. You can define um, more data types. So O stream is another one, which essentially means a output stream. Cin and sorry, C out also uses the same stream, but we're explicitly using it here for so it's a reference. Okay, with the operator. Use the yeah. What I'm doing is overloading the bit the left shift operator here. Okay. Then it essentially takes O string. I'll maybe put it as standard to avoid the error string. Takes some kind of input and then the complex data type, the user defined data type. um, Const complex. Then yeah, I'll have what we're essentially trying to do is to focus on the body of this function. So we'll have standard cout. Okay, it will have something like this. Uh, then yeah, so the C what do you call it? The complex number it takes in its the real part. Okay, will print. Then we'll just put a comma to print the imaginary part now. So essentially the idea is that we're overloading the left shift operator, right, to print this complex number. Uh, Normally, you can't print complex data types. So, as in, let's say I define a complex number C, which I will do now, and then return. Okay, so this ends it, and then I end the class. Right. So what I'll do is define complex C1 as I've written a constructor, but that's okay. You can just use it this way. Let it be like 4.5 comma 8.9. Another complex data type. So C2, which yeah, we can use it this way now. So this is uh, this doesn't require a constructor, but since we have a constructor, we can pass it this way also. So let it be like 6.3 comma 3.6. Okay. So this will use the constructor. This doesn't this will use the default constructor. Here it uses the constructor that we have given. Then yeah, now I'll try to print. So have like C1, the first complex number. Then yeah, we just put comma. Let's put this and then C2. I'll separate because these will use comma. So let's separate the actual numbers by semicolon, and then we can just end it. Okay, let's now see and print. It might throw some errors, but let's see. I hope the idea itself is clear. Yeah, it's a non-aggregate. I think shows the list. Um, anyway, I hope the point of it is clear. So what we're trying to essentially do is because the complex number C1, like the C1 is the object. So if it, let's say I want to just pass C1 to Cout, C1, the object to a Cout, it will just throw me error. The reason for that is uh, C1 itself is a custom data type. Operator is not overloaded yet. It doesn't know what to do with this. What we can do is overload the shift operator, okay, and pass like overload it such that inside complex class itself, so that we can print the real and the imaginary parts. Okay. Now, why do we have to make it a friend class? Because any guesses? So I hope don't stress too much about the data type. It's just uh, what we're essentially trying to do is making it we're using the operator to say that the shift operator we're overloading. Okay. And this is a way of taking inputs. is what it will happen when you push, when you try to pass C1 to left shift operator. But can anybody tell why does it make it a, we need to make it a friend class? Any guesses? Like not class, friend qualifier. Essentially, the reason for that is because this operator is also accessible outside, right? So standard cout should be able to use this see this function, because in standard cout also it is defined the function that we have done here. Eh, it's just that we have overloaded here inside complex class, so it will see that the operator definitions that it has in itself. So we saw all these definitions, right? For integers, for long, for float, for double, and so on. By having a friend function, okay, inside this class, this operator left shift is now overloaded with some extra thing. What is that extra thing? The extra thing is that now it can use complex data types. So essentially, that is the idea behind overloading even these shift operators, so that we can print even complex numbers. Okay, I hope the idea is clear. Okay. Mm, this is complex number, so maybe we'll just fix this. That should fix the error, I hope. Oh, great. So yeah, I mean, essentially, since we have defined the um, constructor, let's just use that. And as you can see, we are able to overload the shift operators, right? Defined already inside standard cout to use this shift operator for complex class. So that this function now, so this double operator, double shift, this shift operator is now overloaded. Okay. Any questions? I hope this is clear. Yeah. Okay. Right. Now we can look at maybe some IO functions for files. Okay. Yeah, let's do that. Okay. So what I'll do is we have the usual IO string. Now these are generally used for like uh, variables mostly. It's like data streams, but for you can think of like just custom data type or variables and characters and so on. I'll just do this. But let's say we want to work with actual files which are stored inside uh, your hard disk, your SSDs, mechanical or SSD, anything. So any kind of storage device, they could be inside the system or the computer that the code is running. So let's say the code is running and first it gets to RAM, right? And the CPU accesses it and runs all the codes, everything. Let's say it is connected to some storage. Now the storage, let's say, has some file and we want to access that. Or also it is routinely done that you have your code runs, it has some output to write. Okay, so it will write to the disk. Now this input and output of files is the file input output, which also uses streams, right? But it's a little different. I hope the distinction is little clear. So there we use to use these C++ says uh, functions. We use so essentially it is file stream, and it has useful functions to read, write, and then output these um, again, not output as in it's output, but again write to a file. Okay. Now the nice thing is it's an object, so you can have useful functions through it. Uh, so even file handling becomes easier because then you can have uh, some error checking inbuilt to the function. So that is useful. So instead of just calling the other In so what happens in C is these objects are not, so these files are not objects, more of like pointers. So you're actually pointing to that place. So becomes a little tedious, and managing even errors also are not uh, that useful, because you won't have error messages with them. So with C++, that's one very useful thing. Okay, so let's see how to work with files now. Okay. So what we'll do is have again the main function return 0. Okay, now yeah, I'll have an output. So many times, oh, another important thing. Uh, I mentioned about the file connected to the sorry, a hard disk connected to the system. You can have file a sort of a network file storage, which is shared across systems and or computers, like you have in supercomputers or clusters, where uh, a collection of hard disks or a collection of a sort of a storage is shared across different computers. So even networks also, you can use print, like have file access as input and output using these objects. Okay, it's not just the same computer you have to do. You can have in both cases, like all of these cases actually. Okay, so let's have like yeah, call it my file. Then what I'll do is, so essentially I'm making an object of output stream. Okay, so which will be my file. And what I'll do is use this my file to open. So essentially I'm saying uh, I have an object which will act as like a storage for all my output data that I'm giving. And then when I write this and give a file name, it will essentially write to that file. I can put like test.txt. Okay. Then now what I can do is just like streams, just use the shift operator to stream all my data that I want to put. So I'll put like mm, hello world. Okay. Then I'll end the line. Maybe I'll do it this way. Just end the line. That's it. Uh, Extra thing I can do is maybe no. Let's just let me write my file. I'll put some numbers. So let's say 1, then end the line. 2, then maybe 7. Okay. So now what I can do is all these uh, things I wrote. It's like essentially think of it like I created an object which will act like a buffer you can think of, which will store all the data I want to push out from my code. Hence the output for the code, and open that object now it with some name. So essentially it will be like all this very data I'm writing to my file essentially goes to this and gets saved into test.txt. I do all the output that I want. So let's say some uh, output that I wrote. Then what I do is I just close that file. Okay. What this will do is it will flush out all the data that we are writing to the buffer and save that file. Essentially, that's what this line does.
Sir,
Yeah. Go ahead.
in the same question, in the same program, I have
Mhm,
one question. Like
mhm,
whenever we are opening this file, we
mhm.
are not mentioning it is for read purpose or read write purpose or just
Right. Yeah.
so.
So how does it know? Yeah. So thing
Yeah.
is, because here my file is of output type, so it will be of write type. So that,
Oh,
yeah, it will know from that how to put it, the data type. So because my file is of
output
output.
type means. Output type means we are getting output from that file, right?
No, no, no. That's the thing. Hence I say. So output is with respect to your code. Okay. Always
Okay,
remember
okay,
output or input is with respect to your code. So if you see here, input, Cin is input. Input for what? Input for my code or to my variable. Output from my code, which is hello world or A or B or C. Okay. Similarly, output, the my file object, whatever, is output from my code. Yeah.
okay,
Yeah.
okay. Output from my code.
My code.
So
Yeah.
instead of it is printing on the screen, it is printing on the file, in the
On the
file.
file. Yeah.
Yeah.
It's like it will go to a buffer first, and then that buffer gets stored inside a file. But essentially, that's the idea. The output is into a file now. Instead of just screen, it is to a file, and the file name you can just give something like this. Yeah.
Yeah, got it.
Yeah. So I'll just put this, and yeah, great. As you can see, this file did not exist. Maybe I'll just delete it and then rerun. Yeah. there- So notice, I don't have. Okay, maybe I can do this also. ls just has these CPP files and then whatever the executable that I created. So if I run this file, as you can see, that file got created. ls if I do, the test.txt also gets created. Let's see the contents of that file. So yes, as expected, I have hello world that I put, then 1, then 2, and then 7, and then I close the file. So yeah, that's what happens. We have all the output. Now, thing is this way of writing this file, like file IO, is explicit in the sense it is intuitive, and then it is how to put it, less prone to errors also. So because there's a proper logic to the whole process, you define the type that you want. So let's say I define just O f stream. So O itself, like I said, it's output. So you can also define f stream, but then when you open the file, you have to mention with a comma what's the type that you want to, as in what mode you are opening it. Is it read mode? Is it write mode? Is it append mode? Or and so on. Okay. With you can be more explicit also this way, or you can just always use fstream and then give what kind of read write or something, because this file doesn't exist. Read mode you can't use. We can just use write mode and then write to the file. Okay, nice. Then go ahead. Okay, so what we're doing is opening the file, like saying that this will be the output, writing all the contents we want, then closing the file. Okay, so closing the file also is necessary because what this step does is so like I said, mentioned a buffer, think of it like a storage. So all these things will storage in the sense these are in RAM right now, and then flush to the disk, so which is the location of the test.txt. Now the other useful then thing about closing it is now the program can say that I'm not accessing the file handle for test.txt. I created the file, pushed all my changes, like what I wanted, and then I'm done with this file, and I don't want I no longer have any access to it. So some other file can then open this and then change it. Okay, essentially that's the way of handling access. So that at a given time, any given time, a file should not be opened and written by multiple processes. Okay, so that's that idea is inherently taken care of when you do a process like this. Okay. Now, when you have multiple processes running, so let's say when we use MPI I understand it's not covered in this course, but just for to give a like general idea, when you use OpenMP where you have multiple threads, or MPI when you have multiple processes, you have to be very careful while doing file IO, because if same file is being accessed by many processes, then the output will be just garbage or disastrous. So again, it's essentially uh, the idea is to avoid the same file being written. Reading is okay because if the content is not changing and a process is reading different parts of the file or the same file and then interpreting it on its own, that is okay. But writing to it should not happen. So you'll have uh, race conditions and other issues. But essentially, that is an error. I hope that is clear. Okay, good. Then, yeah, so we did this. And then let's write another program, which will essentially read from this. Right? We wrote to it. So hence the output. Okay, so my bad. Hence the output. Now we'll read from this. So similarly, I'll just include hash include IOStream. But this time I want the files to be worked with, so stream also included. And that's it, I guess. Let's see if we need more header files later. This time I'll have a standard if stream, like input f stream. The convention for input and output also in a way makes sense because you're writing a program. If you think about it, if you're writing a program, it's the reference is your own program. Now every other output or input can be thought from this reference because it's not necessary that you'll always have a storage attached to a program like a system, right? So you can, if there is a storage attached to it, you can probably push some data to it, so it'll be like an output. Or right now, like, or similar to what we have been doing all the time, go some screen, okay, in the terminal or anything, right? So hence probably the idea behind uh, having input and output with reference to the code was the um, standard is what chose it probably. Yeah. So what I'm doing here is if the input stream reads test.txt. So the important thing to notice, this file should exist when you're going to read mode. If the file doesn't exist, it will throw an error. Okay. The object is my file. Okay. So I'm saying that I'll read the contents to of test.txt to my file. Then we will start with a this time I'll need a string also. Okay. So I'll define a standard string line. Okay. I can have a condition that if my file is open, well, like is open function I can use. So essentially it says if it is open, it will run this part of the code. Okay. Or else it will exit. So when does that happen? While writing the code, we'll have a exit statement also. So there'll be a while loop, which is essentially like get line for my file. Probably it will require standard. Let's see. Uh, my file will pass the line. So essentially the idea is that you have a function getLine, which takes my file, the object that we're reading from, okay, and pushing each line to the string line. Okay. I can probably just do this. Pushing to sorry. Sorry. So the get line takes the object my file, okay, and pushes each line to line, okay, which is a string. So essentially it is like you're reading each line and then putting into line, and then we'll manipulate this line. So it's like has the while loop, okay. So what we'll do is just read it and print it. We don't need to work on it or anything. It's just let's just print it for now. So print the line, okay. and then I'll add this new line. Okay. Um, yeah, I don't need to end like there's no parenthesis needed because this is just one line I have. So I'll avoid writing that. Then what else? Yeah, after this line is done, I can just close it. So this will be my exit for this if statement. Okay. Once it knows that it's done, then it will exit anyway. The nice thing is, yeah, this should fail because no, as in this won't work if your file is already open. Think about it. That's one to check it will have. Okay, that is the if part, and then we can put an else for this, which will be say standards out. Sorry, yeah, file is already open. That's it. So that's this code and then this code. Yeah, you'll probably push it. Yeah, okay, that's okay. Right. So let's run this part. So since we already have the test.txt from previous run, okay. So let's read this and then uh, so run this file. Okay, great. So yeah, uh, we saw the example of OF stream, where we're outputting data to a file, like as in from the code to a writing, then writing to a file. So that after it is done, we created a file test.txt, okay, with hello world 127 and everything. Now what we're doing is inputting as in reading from that file. So input to the code. So if the if stream is defined for that my file object, okay, and then we're saying that this from this file we'll read and associate this object to that file now. Okay, we define a line, variable line with string. Now the idea behind define this line is when I run a get line, okay, what that will do is it will run, it will as in uh, input values like each line from my file to line variable in a while loop, as in first we'll input first line here, hello world, this is what we see into this line. Okay, yeah, sorry, into this line, and then what we're doing is printing it. So standard cout line, then putting a new line. So it will print it, it will read hello world, print it, that's what happens line. Then another again it goes back, it says a while is also a loop, right? It will go to the my file again, read the next line. So next line now has one. Okay, so it will print one. Okay, overwrite the old val characters inside line, which was hello world, and put that as one. Then new line, and then so on. It keeps going until it hits the last line, and then after that there's a new line essentially. Okay, so when or you can think of like end of file essentially. Okay, so when it hits end of file, it uh, the while loop gets an exit because get line will be false. So there is a output to get line. As in general, when it's getting a line from my file gets successful, it returns a true value. So while loop sees that true and runs the line, runs the body of while loop. Doesn't have to worry about that for that line. So it will, if when it says when while sees true, which happens when get line gets any new line from the file. Okay, then it executes this standard C outline where it prints the line that it got. When it gets a false, so it exits. Okay. So the nice thing about doing it this way is because a lot of times we don't know uh, how many number of lines are there in a file, and we want to keep uh, inputting it, like streaming it, the all the input until we like are through with the file. So a line like this is very useful in that case. So where it automatically exits when it encounters end of line, end of file. So there are special characters which define when a file is ended, or when a new line gets added, when a file gets ended, and so on. So this we don't need to really worry about them. It's essentially like when those characters are encountered for functions like getLine, or so for getLine it is end of file. So when end of file is encountered, it automatically exits. Okay. And then while after this while loop is done, we should obviously close the file so that the handle gets freed. Now the file test.txt is free to be opened by any other code. Okay. Now what the usefulness about of this one, if it is I think the is open is not exactly true. If it is open, then it should not execute this. Will probably as in you can think of it like if it is open, uh, it won't execute this. Okay. So if it is not open, then it will execute, else it will say file is already open. Okay. Yes. So it's anyway read-only mode, so not an issue from that perspective. I shouldn't put it as file is already open, unable to open file, something like that would be better. It's a or anyway read-only mode, so multiple multiple process can open this. So that's not an issue. Yeah, that's a nice thing about C++ IO is that it is type safe. So when you have you might have seen, if you're familiar with um, C way of doing the same thing, it uses printfs, and you have to uh, give the data type as percentage %d and all that for integers, and percentage %f for floats and all. There's a lot of potential for making mistakes with at least C++. It is pretty much clear, and yeah, it's less prone to error, at least what um, the idea behind was while making the standard for C++. Okay, so we saw the stream manipulation. So we saw the stream manipulation here, which is the standard hex, the standard opt. You can manipulate stream using this. The other way of manipulating is what we saw is for decimals at least. You can have set precisions, which is 16 or something I just gave for float, and again for double also. So these are the ways you can manipulate streams. Then what else? You can yes, okay. Mm, yeah, that's all. Yeah, I have covered this before, but maybe you can take a look at this again. I'll just quickly discuss some of the generic containers available in uh, standard template library, the STL library. You can probably pull up from previous weeks also that I discussed. Just give me a second. Yeah. So thing is, in general, when you're trying to program, you can have uh, different ways of programming it. So like you're trying to access some data, trying to find the maximum of a given array, any such questions it might have encountered. Now, the nice thing is the standard template library provides you with useful containers for doing all the manipulation you want to do. So let's say you want to find the maximum of a given number. Like it's a list of lot of numbers, and then you want to find the maximum. So in your thought, you'll have some kind of algorithm to perform this code, right? So you have a generic algorithm, and then you want to work with some container in maybe to do this. So that's what the nice thing about programming is, as in the C++ standard template library, it provides you with containers to do the same. So we saw this before. So a vector is a useful class where you can have a list of integers. So let's say size is 15. I gave this example before. So its size is 15 and it's a list of integers. So those you can then store, then resize even the, it's dynamically allocated. So you don't have to worry about size at the runtime. You can change its size at runtime itself. So I can change size to 20 and then write more values. So here I was trying to print the size, and the good thing is the vector will keep its size known by these methods, right? So size will give you the current size of the vector. Then you have um, like you can just input some values like I did here and then print them, or you can access them by pointers also. Essentially, these data types like vectors or even arrays are quite useful. The difference is that with vectors, these are dynamically allocated. So its size need not be known at even compilation time, and you can just vary them during runtime itself. But with arrays, these are, oh, the difference is this is stored inside heap, which is generally on RAM, and this is arrays, so standard arrays or C-style arrays. These are stack allocated, and then condition or the necessary thing is that they need to be the size, okay, needs to be known at compilation time. Something like its data type is, so it's templatized, so it has to be compilation time constant. So for a standard array, you have to give its data type. So let's say I want to store integers. I'll store it first argument. I'll give the first argument as integer. Then I will store. Then I'll pass the size of it. So 10. So during compilation itself, it will allocate 10 uh, times memory of integers so that I'll store these values. It's much faster than sorry, using vectors because there's a stack allocated, which is usually the memory is in cache of the CPU, which is a pretty fast access of memory. Okay. And because getting data from RAM itself takes a time, so it takes a while. So it's a slower process. So using vectors are slightly lower. Slightly slower. But the main difference is that using arrays, while you get the speed, the downside to it is you don't have as much memory that you have while using vectors, because vectors are stored inside RAM. RAM has much larger pool of memory for it to store data. It can be in gigabytes, like terabytes also, if you have large enough
Sir,
RAM. Yeah, go ahead.
sir, but how can we store the array into the cache? Means
Ah,
obviously we have to store into the RAM only, right?
no, no, that's the thing. Automatically, because these sizes are known, and let's say you're not storing very large uh, values. So this, let's say this 10 itself,
Mm,
sorry, I'll represent it by some number n. Okay. So imagine this n to be small enough. So like 10 or 15 or something like that. Um,
mm.
there is a limit to it. So stack has a limit of 20 megabytes in general. You can increase it
Okay.
if your cache allows it. So within 20 megabytes, let's say it's a rough number I'm just estimating. It depends on a compiler system, etc. But let's say this n is large enough that it can't store 20 megabytes. Okay, so this A becomes too huge. Then
Mm.
you get an error which is popularly known as stack overflow, if you have heard of it.
Okay.
So that's
Yes.
when stack overflow happens and you get all kinds of weird errors in your program. Like not even program, your system might crash even. So uh,
Sir,
that's,
that 20, sorry to interrupt you, that
yeah,
20
good.
megabyte, it's for whole program, means a whole memory of cache, sorry, stack, or it's just for that particular variable memory, means whatever
In
variable we are
usually,
assigning.
yeah, usually it is for the whole program, not just for the variable. It's just
Okay.
a default number I'm saying. It's because this was used to be for many programs. It depends. Again, the exact number for it depends on the system that you're running in, the compiler you're using, and many other stuff. But think of it like you can't exceed 20 megabytes, but then again, let's say your cache itself is not that big, so that 20 megabyte doesn't matter. You'll still get Stack Overflow much before that, because let's say your cache is just 4 megabytes. So let's say there's a CPU which has 4 megabytes of cache only. It will already get full and then it will throw error, like Stack Overflow. Um,
Sir,
mhm, mhm,
sorry to
yeah,
interrupt you.
yeah, yeah.
But what is the difference between means not a difference I
Yeah.
know, but
Mhm.
why cache and stack is related means
Right. So think of it like when I say RAM is a physical memory. Okay.
right.
Uh, right. Cache is also like a physical memory inside CPU. RAM is like a detached from CPU. It's not on CPU. It is detached. It's like a
Hard.
separate memory.
Yes,
Right.
yes.
Right.
Separate memory.
But think of this is from hardware level. The same thing when we talk from perspective of software, we use words like heap and stack. Essentially, that's the idea.
Yes.
So I'll use the word heap from a software perspective because I'm writing a program. I want to interface the same thing from hardware, okay, but I'll not use the same word or the lingo, because I'll have the the idea is that I'll use the same word like keep, stack, or heap or something, but my RAM could be something else. So let's say what I call RAM need not be RAM for another system. You can have this is how even so let's say think of it this way. I have a way of writing programs, but I want to be sort of agnostic of what the architecture is, because sometimes your in some systems, like in very modern systems like Grace Hopper H100, the memory which we call RAM, okay, that is shared between both GPUs and CPUs. Generally, CPU has a RAM, okay, it has its own like 512 gigabyte or whatever RAM, and the GPU has its own RAM that's separate. But in modern systems, you have something of think of a RAM, but it's now shared by both GPUs and CPUs. So the same physical I can't call that memory that I'm calling RAM is used for CPUs, and which GPU memory, which you used to call GPU memory or VRAM or global memory or whatever, that was a different name, VRAM. Okay. But from a perspective of software, I can call that as heap. Now it is still heap for GPU, it is still heap for CPUs also. Okay. So for programs to be more agnostic of hardware architectures, the concept of stack and heap is used. Stack is more like we can think of it like, okay, this is small memory and fast access. This is what I want to think of as stack. Heap as more large memory of like pool of memory, but less. It will be slower, but it will have more large memory like that. That's the idea behind using words like stack and heap. Now the thing is, heap is user defined, as in we have control over it. But when you have stack is usually compiler decides it. It can actually think that if this is a stack, this is like array. Usually, it will, if there is space available, or think of it like if there's optimization, it can store it inside cache. It is possible. It is not uh, impossible that it can be still like this is a local memory, but it can be stored inside global memory. As in GPUs, it can happen. You can have this kind of um, arrays or data types inside RAM, because compiler might think that, okay, I have more useful stuff that I want to keep inside cache, and even if this is a array which should be stack allocated, and in a way it is stack allocated, but the actual physical memory is inside RAM. So yeah, it's more useful to think of stack and heaps as a more software perspective, and RAM or even caches from hardware perspective. They can overlap actually. That's a different. I won't confuse you with more details, but essentially you can think like usually stack means cache, usually heap means RAM.
Sir,
Okay. Go
but
ahead.
how we can come to know that how much stack is assigned for
Yeah,
that particular program
yeah,
is
right.
whatever the compiler have assigned,
Right.
and
Right.
how
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 much
we
of
can set it. Means we can resize it.
You can't resize. So stack for a given program is by default a certain limit, like I was saying, 20 megabyte. You can actually change it using some environment variable. I'm not sure how safe is that, but there are ways one can change it. Now, let's say there is a stack allocation for a program, right? That actually is known during compilation time. You can actually pass compilation flags, or you can use even some debuggers and like Valgrind or GDB or something. So those kind of debuggers also will give you more information about your program, like how much is stack allocated or all. It gives you the whole list. In from program perspective, usually it is not it's difficult to know from running a program, but yeah, those kind of profilers and all, they will give you this all this information. Now, that is from that perspective. From perspective of RAM, usually again you can profile it and know from heap also. It is a little easier to know the heap allocation because we usually know what kind of containers are used for heap. So let's say um, vectors and all those are dynamically allocated. So those memory you can just add up and see like whatever sizes you are resizing with. So let's say resize 20 or something. I can add up all those numbers and then, okay, if the same size is same object is being resized, so maximum memory I ever resized it with was so 15 and then 20 and then so on. So 20 is the maximum here. You can get an estimate like how much dynamic memory it used. But again, generally people just instead of doing this manually, people use profilers to get more data. Uh, Profilers have gotten quite good. So Intel has its profilers. So Intel VTune, there is Intel, I forget the Analyze or something, that one, and then the VTune. There's Valgrind, there is GDB. There are a lot of softwares that you can use to get all these metrics. Uh, there are other useful things about profilers also. So let's say not just memory. Sometimes you want to, let's say you're running a program and getting some segmentation faults. Essentially, that means you're accessing memory that is not you're not supposed to do. That usually happens when you're accessing some, let's say a vector, and let's say its size is 10. You're accessing the 11th element. So that's not allowed because vector itself doesn't have access to that data. Okay. So, I mean, you should not be because it's not given to it. So in situations like that, you get segmentation fault and knowing where exactly in the code, let's say you have a very huge code, a lot of files and a big code base. So in those cases, running some kind of debugger is useful. It will exactly point you out where is it failing and all. There is DDT also by ARM that is useful in getting this um, what do you the segmentation faults. In general, these come under debuggers. Yeah, okay.
So,
Any other
so
question?
sorry,
Yeah, yeah, go ahead.
could you please repeat again?
Oh, I meant you can use profilers and debuggers. Okay, so one situation where you get problems is like say you're accessing some values. So let's say for this example, I'm accessing till size. So if I try to less than size actually, if I try to access the size itself, it will throw me an error or I'll get a segmentation fault. Now the reason for that is I'm using pointers here. So like exact dereferencing it around. So that will throw me an error. Okay. And usually it is not easy to find where this error is coming. Let's say you have a very huge code base, thousands of lines of code, and some function is calling something, and inside some call only we're getting some segment. So in those cases, people use debuggers. So like GDB or Valgrind or something. You can even use ARMS DDT. And there are a lot of software, I'm sure, available in the from vendor sites. There are a lot of open source software also. So all these, the idea is that when you run your program with those kind of profilers, what you get is the exact line the error is happening. They are very, very useful in debugging. Hence people use that. There's another
Sir,
class of, yeah, good.
this GDP is a debugger, right?
Yeah.
Then what is the profiler? Profiler means what?
That's the second class of tools. Profiler essentially gives you more metrics about your program. So because some people are very interested inside in just not just running the program, but how well it performs. So as in, can we make the program faster? So knowing the hotspots in your program. So let's say I have a huge code, but I want to know which portion of the program is actually taking a lot of time, let's say. So
Mm.
in those cases, we run something software like profilers. So Intel has some profilers, so like Intel VTune. So and I think Intel Analyze, or I forget the other name. So in a way, you can think of it like at least from um, this is not a, GPU programming course, but at least from just a think of it like your whole program, you can just profile and see which region of the code is actually giving taking the most time. That is one way of looking at it. And let's say you uh, boil down that I have this function which is taking the most time, but then you can analyze the function itself further using more sophisticated profilers where they will analyze every stack call and everything. And let's say how much memory it's taking, how much time it is spending inside the CPU, or fetching data from the RAM and etc. So all the instructions inside the function itself you can analyze, and that's the job of the profiler, essentially. Analyze it is more from the perspective of performance, not the runtime, as in accuracy or the correctness of the program. For that, you have.
You
Hmm,
mean to say, just like
hmm,
whenever we are running some program,
hmm.
let's say we are doing with the help of F10 and F11, we are step by step we are running, means
Okay.
debugging our program.
Hmm,
That time,
hmm.
how much memory means where is the stack, the what is the location of that stack, heap,
Yeah,
and other things
right.
like that way.
That is the work of the debugger. So you know which line
Yes.
is happening what. But let's say
Mm.
I have a for loop like this, and I profile this. I will the job of the profile will say what is which step is taking the most time for me. So the performance
Okay.
becomes the key. Yeah, that is the difference.
Okay.
So in
But it
some,
will not give you the solution for that, how we can
no,
reduce
that
that.
it doesn't. That's the thing. So it
Oh,
will just point to it as then the job of the programmer comes in to optimize it.
okay.
Yeah, it's more of a useful tool to get more insight into the program. Yeah,
Yes, yes.
yeah. If you have more questions, I can take them till last minute, or you guys can feel free to leave. Okay. If there are no more questions, we can end the class here. Uh, I hope you guys understand the concept that I'm covering. So if not, then you can obviously ask in the sessions. You can post your questions in the forum also to so you need not wait for this week and uh, ask here. And do definitely practice. So the more you practice, again, you understand these concepts and all. So yeah, see you guys next week. Happy program.
Thank you, sir.
Yeah.